Now it's time to move on to the next presentation. The next presentation is by JP Perreault, and he's going to talk about X-ray inspection technology supporting your PCP. So, JP, welcome to the stage.
Thank you. Let's grab the clicker. Well, this is always fun figuring out the clicker. Thanks, everybody. Today, I'm going to talk about innovation inside of X-ray inspection systems, how it supports your PCP for foreign material specifically, inside of food processing and beverage facilities here in Canada and throughout the US as well. Maybe. There we go. So agenda-wise, I'm just going to tell you a little bit about who we are as a company, X-ray Reclaim, which is Division of Plant Automation. Talk about also inline inspection today, where it is, existing foreign material inspection technology, basically the levels of technology that are out there being applied throughout the industry today, and growth of X-ray inspection that we're seeing. In doing so, we're going to definitely go down the road of X-ray 101. And then where we are with the latest innovation, which is really the point here, is photon counting technology. So just quickly, Plant Automation was started back in 2009. We're primarily a food inspection company, providing inspection solutions in line for food and beverage processors. These can be metal detectors, optical sorters, vision systems, checkware, but primarily today we're focused mostly inside of X-ray technology. So we're partnered up with the Eagle PI, Mettler Toledo. We have a total of well over 600 solutions installed or systems installed throughout Canada in different food processors as well. These solutions are basically, when we work with clients, we're working from our facility in Bolton, Ontario, which is a food safety inspection center, 15,000 square foot facility where we house our team of project managers and engineers to assist in the implementation of X-ray technology for food companies looking to do that. A little bit of background on Eagle PI. It's a Mettler Toledo company who acquired Eagle PI from Smiths Detection, which is what you see in airports. So Smiths is the innovator of X-ray technology. They've been around for multiple decades, I would say probably 60 years or so. And have always been at the forefront of innovation, which is the benefit that we have in working with Eagle PI here in Canada and the US. So different technologies for advancements of things like morphology, which is essentially passing thresholding, which is the first set of principles inside of X-ray, basically when X-ray is first brought to the marketplace. Check weighing and material discrimination, all these things we'll touch on a little bit, but Eagle has been at the forefront of that right since the get-go. X-ray Reclaim was something that we started, established back in 2020, when, again, we've been pretty prevalent inside the food safety market, working with food processors, started to approach us to rent X-rays, and we, of course, obliged, and then delving into it a little bit more, asked ourselves a question, what was the purpose and what was happening? And honestly, it came to light that there was a need inside the marketplace for essentially providing a service and professionalizing a service to respond to food processors that were looking to mitigate loss due to foreign material contamination inside their finished goods that they'd placed on hold, which today equals north, and the figures are difficult to ascertain, but basically $1 billion a year inside the food processing market here in Canada. Finished goods is going to landfill for this problem and others. So it's a solution we professionalize and also establish a project management team and a dedicated food safety program group to bring the principles of food safety in delivering this service, that we do so mobile as well as inside of our facility. And it's all based around what I'm going to tell you today, which is photon, talk to you about today, is photon counting technology, or PXT, which is the latest in detection. So launching into basically where we are in sort of numbers, CFI does about 2,800 investigations a year for foreign material, foreign bodies, related incidents inside the market. That amounts to a significant amount of impact to supply chain for food processors and beverage processors. When you have on-hold finished goods, obviously we're operating within food safety programs, but it does have an impact to supply chain, which hurts the company. Obviously, inside of having on-hold finished goods that have suspect foreign materials, 9 times out of 10, and I can tell you with a pretty solid level of knowledge at this point, after 4 years of doing this, that most food companies don't understand that there's an option for addressing their finished goods. And so basically you're dealing with having to rerun the product, and that has impacts on your sustainability as well as puts pressure on your operation. So it's a problem that needs to be solved. So looking at a typical, this isn't typical, but this is a pretty extreme inspection zones that you would have in an example here, a meat processing packaging plant. An inspection solution for bulk through to post-grind, if people are familiar with how meat products are formed, post-forming, and then post-packaging. So there's lots of opportunity to introduce metal detectors or inspection solutions, whether they are metal detectors or x-rays, at different intervals. And most of the time that in our experience, food companies and food processors are only putting those solutions at the end of the line, which is a good place to put them, obviously, from a vector contamination standpoint, where your product's in the package and you're performing final inspection. It's definitely a necessity, but there's opportunity to do it further up line because of impacts to breaking, in this case, breaking bone down or introducing incoming materials that can damage different mechanical devices and further fragment foreign material downstream, making possibly, for example, if you're bringing in incoming materials that, you have a foreign material that is 5 millimeters in size at the beginning of this process. By the time it goes through your mechanical processes and processing, can fragment down to below a millimeter, and then metal detector is not going to find it, and an X-ray might not, and single energy X-ray won't find that either. So it's important to look at the whole picture when you're implementing inspection tools in your processing and packaging lines. So where we are today is basically the metal detection marketplace is still there. It's prevalent inside of most food processing plants. When people think X-ray, they just categorically think X-ray. They often don't understand that there are levels of X-ray technology available today, and that's what we're going to talk about. Single energy is the majority, I would say 98% of the X-rays that you might have seen inside of food processing plants. These are better than metal detectors in some respects. They'll get you dense contaminants, of course, more than just metals. They're conductive and magnetic. But they're going to give you more contaminants like glass and stone, high-density foreign materials. And we all know that foreign materials inside your food processing facilities extend past ferrous, non-ferrous, and stainless. So that's where single energies can play a role. Newer technology, which is what we're talking about, is photon counting technology. And I can tell you from my teams here, when they unboxed their first PXT photon X-ray 4 years ago, they had to take a seat. They were pretty blown away with the ability of these new inspection devices, which is a byproduct of the medical industry in developing photon counting technology led by Siemens. And now it's embedded and available inside of, at least the detectors are available inside of commercial devices. So just to put it in perspective, kind of the things we know are ferrous, non-ferrous, and stainless. Metal detectors, typically everybody understands you're going to get 2 to 5 millimeters, depends on the size of the package, nature of the product. Single energy X-rays, you're going to make a dent in that. You're going to get down to 1 millimeter foreign material in terms of stainless, ferrous, non-ferrous, and stainless. And then you're going to get some dense foreign material in there as well. Photon counting, down to 0.3 millimeter. So it's kind of mind-blowing, but also because of the technology that this would be a 2-hour presentation to fully describe how the technology works. But this will also give you material discrimination, which basically means you're going to be able to get plastics and rubbers with photon counting down to a degree that is unbelievable. So for a number of drivers inside of the marketplace, and this is a topic near and dear to me, is sustainability as well. But food retailers are starting to push for X-rays. But also a need and awareness inside of foreign material contamination, heightened food regulations, the social media aspect of this as well, the impacts of companies. There's more attention on foreign material contamination and the application of better tools. And what we've seen, and this is our data, is basically metal detectors were always outpacing X-ray sales in terms of what we're implementing inside of food processors up until about 2022, and then there's been a steep decline. And that's probably mostly because of Costco, but Trader Joe's is following suit. Some food retailers have decided not to push that just yet, but the pressure's on, and I think it's just a matter of time before it becomes the standard. It just makes sense in terms of improving your food safety practices. So jumping into principles of X-ray, for some of you may know how they work, others may not. It's really a two-step process. The first thing we have to do inside of how an X-ray works in performing the inspection is you have to generate an image. And that image is generated by emitting X-ray energy from an X-ray generator, X-ray tube. And that X-ray energy is generated down to a detector, okay? And the detector is kind of the secret in the sauce. The X-ray energy, there's a manipulation of that, the amount of energy, so on and so forth, but the detector and how it receives the information that passes through the product that's conveyed through that beam, that detector basically translates that digital information or electrical signal to a computer to process the image. Okay, so once the image is processed, the grayscale image is processed, the second step of what are the tools sitting behind the curtain to analyze that image, to look for foreign material or defects or do a mass weight measurement. There's a number of tools available, but when you're looking for foreign material, now you're doing this in an automated way. You can look at that image multiple different ways with multiple different what we call operators to look for wire contaminants, to look for different types of discriminant materials. It's pretty robust in terms of when you're processing that image. But the image quality, that's key. And that's really where photon counting comes into play in generating a 300% better grayscale image. So jumping into detectors, single energy detectors, pretty remarkable technology at the time, but essentially you have a series of diodes, and it's a two-step, they're called energy integrating detectors. It's a two-step process. When the X-ray energy passes down into a detector array, and this is this box up top, basically this detector array has a series of diodes sitting below it. But the X-ray energy basically excites a ceramic material that emits light that is measured by those photodiodes that generates an electrical impulse. And that's the electrical impulse that then is transmitted for further processing by the CPU. It's a two-step process, but it's got inherent limitations. And again, without getting into too much detail, what you're doing is you're basically measuring the X-ray energy, you're converting it to light, and then you're measuring that light. And when you're generating light, controlling the light from diode position to diode position requires isolation, and then you're getting blind spots. Essentially, you're getting kind of a low-grade image. If you think about 30 years ago, getting an X-ray image done at the hospital or your dentist's office to where we are today with the newest and latest CT scanners, it's night and day. Photon counting basically eliminates this whole thing. So it's a kind of a game changer. They went into the X-ray and they just tore out the old detector and they said, let's start new. How can we measure X-ray energy or photons? Directly. And through a crystal semiconductor, the X-ray energy passes through that, and its dissipation through that will generate, based on its movement, generate a measurement of electrical energy that's immediately generated, eliminating the two-stage process. This process also eliminates blind spots. So not only is it more efficient, you're getting more compact information, you're getting material discrimination because we know where it's positioned in terms of organic or inorganic. You're getting essentially, to put it in layman terms, 300% improved grayscale image production. The result is essentially a tremendously enhanced image quality that then gives you a major starting point. Instead of starting at the batter's box, you're starting on third base and analyzing that image. And this gives you a sense of, this is an image on the right, single energy, traditional single energy. So that's X-ray bag, I believe it's of a lettuce product. And then with the enhancements available through photon counting, you can clearly see the contaminants. So traditionally, when you're looking at an X-ray image, if you can't visually detect it by staring at it and kind of going, well, maybe I see a stone, maybe I see some stainless steel in there, that's going to, if it's difficult for you to do it, it's going to be difficult for an algorithm to do it. So the better the image, and you can see on the right with photon counting, pretty easy to nail. This just provides you a chart, and I included it because the presentations will be available to you afterwards. It gives you sort of a ranking of this, but, and I'll talk a little bit more. We have, inside of our food safety center, we have the ability to provide all sorts of testing for you, and I'll jump into that in a bit. But this is a comparative chart between where metal detectors lie, single energy, and PXT. So the case for PXT is, the drive for better food safety, doing the best possible, implementing the best technology. Isn't always been, and I know everybody's got a boss in terms of budgets and implementing inspection tools and doing better. It's the overarching mandate, but in the end, there's a budget to consider and an operation to run, and food safety is a very primal thing that we're all concerned about, but doing better inspection, PXT is definitely that. The case today, though, is for C-suite and upper management inside of organizations considering inspection and doing and implementing the best possible technology. We're starting to see a major push towards reducing food waste, obviously with our X-ray reclaim division and that service that we provide to food processors, but also choosing to implement photon counting technology directly into their lines. Not necessarily because CFIA is demanding it, because they're not, or Costco's demanding it because they're not. By being able to inspect below 1 millimeter for foreign materials that they didn't even know were there, they're able to actually reverse the course on waste inside their facilities, because this is helping bring them information about where vector contaminant points lie in their line, be able to analyze and change materials, plastics and rubbers, to become more inorganic, or make them more inorganic so we can detect them, and improve the overall outcome to the operation by reducing the amount of product going to landfill that was previously put on hold. The main kicker point for food processors in implementing this high-level technology inside their inspection lines is really sustainability. And that's a real metric. We all talk about it, but if you put your head into it and understand how it affects the stock price of companies, it's been studied. The volatility in stock prices for food processing food companies is directly affected. It's the right thing to do for sure, but in the end, it means that your practices that you're implementing across the board from a sustainability level actually make you a better company. And that's in line with what PXT will do for you. So visually, basically, showing you my visual here, PXT photon counting technology, it goes beyond food safety. It really does transform a food processor's business. It just delivers more comprehensive and precise detection of foreign materials. But really, the bottom line, it's not just about food safety. It's about being smarter, more sustainable operation that drives long-term value for companies. So this is just our operation here in Bolton, Ontario. So we have multiple inspection lines for when you have food safety foreign material incidents that we respond to. We have availability inside of our facility to inspect using PXT technology, which is strictly all we use. So foreign material incidents can be handled in-house, or we deliver the services mobile, which we do throughout North America, working for some of the largest food and beverage processors that there are. And we all do it based on a very stern food safety program that provides inspection validation, inspection conformity, and full traceability. These are some images of some of the materials that have been found. So here you have 2.4 millimeter bone inside of a bag. Here you have a pouch of baby food down to 0.2 millimeters detectable. Plastics and rubbers down to 2 millimeters. And this is an X-ray image, which we can also X-ray inspect full cases rather than individual packages if the POD is acceptable. So we're doing full case here and detecting a bolt. And this just gives you a quick video of how we managed to achieve a below 2 sigma inspection using PXT technology. So the product is unpackaged in this case, and we're dealing with shredded cheese. So the first inspection, so we're doing back-to-back X-ray inspections. And then between the systems, you'll see where we're inverting the cheese to go through a second. That gives you, understanding the X-ray technology, of course, foreign material could be in a position in the package and an orientation in the package. So this gives you inversion, gives you a better probability of detection. And then we're just doing a final sweep with a metal detector. So all this data is collected, every X-ray image is saved, built inside of our traceability report. Detected foreign material is isolated in the cage, quarantined in the cage. And then, again, the product is brought in, inspected, and then returned to our clients. So this is our operation in Bolton. So with that, I thank you.
Very fascinating stuff. I just read that X-ray Reclaim actually saved 2.5 million kilograms of products and saved $150 million worth of product going into the landfill, supporting more than 350 companies. So amazing stuff. So.
And very, very busy with the Compass Minerals salt recall, which affected piles of people. So we've been running 24 hours a day, 7 days a week.
Great. Any questions for JP?
Casey?
There's none. Can I ask you a question?
Sure.
So when you do all this stuff, who takes the legal responsibility for making sure the end product is free of those, either the metals or any other contaminants?
It's a good question. So essentially, our job is essentially to do an investigation and using inspection tools. We're generating a report, and then our clients are basically acting on that report, making their own decisions based on their food safety practices. So it's no different than when they're inspecting using metal detectors or X-rays in their own lines, understanding what the probability of detection of those devices are. What we're doing is doing a re-inspection based on our inspection validation that we do. So all we're doing is basically inspecting, isolating the contaminants we find, and generating a report. That's the beginning and the end of our responsibility. On that foundation, it does provide food companies the ability to decide whether to destroy the product, which they have done in some instances, or release it.
Okay. And would the food regulators accept your certification for inspections?
So I would tell you that the majority of the food inspection projects we've done, the CFIA is already aware of it, and the CFIA has been in our facility, so there's been oversight on this salt recall. So our methodologies are at the highest standard for inspection, conformity, and validation, and they meet food safety standards. Because we're handling packaged product, there's no probability for recontaminating products. So we would never handle raw products inside of our facility. That's where mobile inspection comes into play, where we will dispatch into bulk meat, poultry, fish operations to inspect with hygienic new belts. So
Great, thank you. Any other questions?
great. Well, thank you.
Great, thank you all. Thanks.